Okay, so this is section 2.4. Begins on page 76. And we're just going to go right to example 1, and I'm going to show you how to handle it. Okay? Are you ready? You got to be reading it with me so you can see what I'm getting out of the words. So get to page 76, example 1, and read with me. We'll pull information out of there and get it done. Everybody there? Okay. In example 1, you need to have your eyeballs on the graph that is to the left of the reading. I'll read it to you, and you take a look at the graph and see if you can make it make sense. It says, the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet, and x is the horizontal distance traveled in feet. Write an equation of the parabola. The performer lands in a net 90 feet from the cannon. What's the height of the net? Okay, I want you to look at that graph. Let's study that for just a minute. How high is the cannon when he gets fired?
50 feet.
Do you understand? Is he correct? Do you think that's right? You understand where he's getting it from? 15 feet up. It looks like the net is a little higher than 15 feet, somewhere between 20 and 25 feet, right? If he's going to land 90 feet away, because look at how the x-axis is numbered. Each one of the lines is 10, even though they only go 20, 40, 60, it's every other one. So each line is 10, which means that the very last vertical line that you see there in that graph is associated with 90, and that's where they asked us to find the height of the net at 90 feet. Is that right? So we expect that to be somewhere between 20 and 25, probably closer to 20, but that's not good enough. We're supposed to find it exactly. What that means is we need the equation of this parabola. You're going, well, how the heck do I do that? It's not as hard as you think. You may not be able to come up with it on your own, but it's not as bad as you think. We go with, when we get to write the equation of a parabola, we go with the equation that we like best. And I'm telling you what you like best. You like the vertex form best because it's much easier to read for all the information you need. The vertex form, okay? Now let me remind you what that is. Vertex form is y equals a times x minus h squared plus k, where the vertex is hk. Do you recall that from studying so far this chapter? Okay. A tells us about how the thing opens up. The A in our case is going to be negative. We can tell that because of the way the thing opens, right? Can't tell what size it is yet. Here's the thing that I haven't asked you to consider yet. I want you to look at this equation and carefully, in the whole equation, how many variables are there?
5.
I'm seeing 5 from back here too. Anybody have any different number than 5? Okay, let me tell you about these variables. You know what this does. It opens it up or down, and it makes it fat or skinny depending on its size, right? You know what this does. It moves it right or left, the opposite of what you see. This moves it up or down off of the origin, exactly what you see. And this combination moves it right this far and up this far. Well, not right, but right or left this far and up or down this far, right? I mean, correct? But what do these guys do? The x and the y. I'll tell you what they do. Think about this and see if this makes sense to you. These remain variables. They're all, whatever x is, we plug an x in and we crank out a number and it determines a y that goes with it, and it's a point on the parabola, right? And there are billions of points on the parabola. So these two guys right here, they generate all the other points besides the vertex. They actually generate the vertex too, but what I'm saying is, we know one point out of millions. We also know one other point out of millions, and it's the point 0.015. See that? So if you know how to use the information they gave you, what they have told you there is a replacement. If you know where to put things, they've given you a replacement for 4 of the 5 variables in this equation. And if you have an equation that has only one variable in it, you have the skills to solve it. So what they've given you is a replacement for 4 of them. The h and the k as a very special point, and the h and the k for our problem gets replaced with 50 and 35. But the other point that they gave us, and it could have been any of the billions of points on there, any other point besides the vertex, that replaces x and y. It's kind of a snapshot of a piece of the parabola. But it will allow us to find out what a is. So watch. We're going to say 15. Y'all see why I've got 15? That's replacing y. That's the y coordinate of the other point. You with me? Equals. The one thing they didn't tell me was a. That's the one thing I'm going to solve for here in a minute. The x, which is the x coordinate of that other point, is 0. You with me? The h, that's the x coordinate of the vertex, which is 50.
Yeah, good.
So it'll be minus 50 because it's a positive h, so we put minus 50. That corresponds to this. Squared. And then the k value must be the y coordinate of the vertex, which is 35, and it is 35 straight up because this is the exact number that you see. Now that you'll have to kind of go slow on this a little bit. But what we've got here, this is in general right here for ours, our vertex was at 50, 35, and the other point, just arbitrary point, was at 0, 15. This is h, this is k, this is x, this is y, and we have a that remains. Do you see the replacements? They've given you 4 numbers. You got to put them in the right place according to what you know about this equation. And it will leave you with an equation that only has a in it. Now, let me show you a stumbling block that some of you may stumble on unless you pay attention right now in solving this. The first thing I would do next, once I've got the replacements, I'm trying to get an a. I would have 15, and then it would equal, and I would have a, and then inside here, I would have 0 minus 50. That's negative 50. And I would square that. Negative 50 squared is positive 2,500. You with me? Plus 35. Nothing happened there. All I did was simplify in here, and whatever the number is I got by the subtraction or the addition sometimes, whatever number this is in here, I squared it, stuck it here. This is that, getting that far, most people can do. Here's the error, the stumbling block that people make. Please don't stumble here. We are used to seeing numbers on the fronts of variables, like we're used to seeing 3x, not x3, right? And so this feels funny. This feels weird. And because it feels weird, people make mistakes. People will take 2,500 and add 35. That's not what you do, folks. Order of operations says you have to multiply these two guys first. So, if you will, take an extra line and write it the way you're used to seeing it. Because if you write it the way you're used to seeing it, you'll remember how to properly handle it, which is to subtract the 35 and then divide the result by 2,500, not add these two. That's what people will do because these numbers are right next to each other. They're not used to seeing it on the back side of a, and they forget that multiplication comes before addition and screw the whole thing up. So don't do that. Rewrite it the way you're used to seeing it, and then solving it's no big deal. 15 minus 35 is negative 20. And then you divide negative 20 by 2,500. You can have your calculator do it, or you can simplify it in your head if you're good at it. If I cancel a 10 out of everything, I have 2 over 250, which is 1 over 125. And if you're not really good at reducing those, then ask your calculator, what's negative 20 divided by 2,500? And then change it to a fraction. It'll tell you it's this. It'll reduce it for you and everything. You just got to do the division. You'll take negative 20 divided by 2,500, and then go math, enter, enter, and it'll give you this. You follow? Okay. Now, the reason we did all of this was to discover the size of A. This is a turn down. We knew it would turn out negative, but it's a really tiny number. So this thing's been severely squashed. I mean, it's a severe vertical shrink. But here's the thing. Once you figure out what A's value is by using this very specific instance of X, Y, H, K, then you got to come back to here and write the equation that can generate all of the other X's and Y's. So it will look like this when we're all done. Y equals negative 1 over 125. That's a specific value that we just discovered. X goes back in as a variable, just like Y did to generate all the other points. But H and K are specific because they are the vertex of this particular parabola. This is your final answer. They wanted you to write the equation of the parabola. So the vertex is very specific to our parabola. It goes back in as constants. The A is very specific for the squashing ability and the opening of it. But the X and the Y return to the equation as variables to get all the other billions of points on it. You see what I'm saying? So this is the equation. But you had to go back, you had to follow all of this stuff to find A so that you put that specific value in for A. So one of the things said, write the equation of the parabola. That took a huge amount of effort. There it is. The performer lands 90 feet from the cannon. What's the height of the net? What is that 90? An X or a Y?
X.
An X. This will be a Y. This is a height. So we use this and we say Y equals, what'd you say?
Oh, I think she said Connor Kennedy.
Okay, well, they can deal with it. He's gone. Okay, 90. We do the order of operations here because we got numbers on this whole side. We just got to clean it up. You can have your calculator do it if you want. It'll be 90 minus 50, which is 40, and 40 squared is 1600. Again, don't sucker for this. It's not this plus this. It's this times this plus this. In your calculator, this is what you would type. Parenthesis, negative, the negative sign, not the minus sign. 1 divided by 125, close it. Then 1600 in another set of parentheses, and then add 35 on the back. What do you get?
42.2.
Is that about what we expected? Look at the graph. Isn't that about where it hits? Okay, there you go. So the net must be 22.2 feet up if that's where his flight stops. It's where he quits, where he hits the net. Okay? Follow that? So if they give you a vertex and an additional point, they're asking you to find A, rewrite the equation, and then possibly use it to make a prediction once you got it written. Okay, look at example 2. Look at the graph to the left of example 2. A meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. So what does X equals 0 represent? What time is it?
Midnight.
Midnight. That's when he started collecting data. So the temperature is going to keep dropping till about when?
No. 12.
Where does this thing bottom out? The temperature keeps dropping until about, looks to me like 14 hours later, to me. Look at the bottom of it. It's not quite at 15, but it's awful close. See what I'm saying? Temperature keeps dropping till about 14 hours later. That's at about what time? 2 p.m.
Yeah.
This is a strange place. Generally, the temperature drops till about 7 a.m. or 8 at the worst, and then starts picking up. Something's happening here. We got a cold front or something coming in here. It's a very strange graph. Either that or they just didn't care when they wrote the book that they should be accurate. Anyway. Is this, in looking at this, would you consider this a pretty cold part of the year or a pretty warm part of the year?
Pretty cold.
Oh,
Celsius.
oh, it is in Celsius.
Kind of warmish.
Fall.
That's still the
What degree Celsius is freezing? Freezing water. Now what do you think? Cold or warm part of the year? Man, this is freezing. It drops to 10 below Celsius. That's about 20 below. No, that's about, let's see, 20 degrees, wasn't it? About 12 degrees. It's about 12 degrees Fahrenheit. So it's not that cold, not like around here, but. Okay, so I just want you to get a feel for the graph and what's going on. And this is over time, starting at midnight. And here's our task. Write a function f that models the temperature over time. Well, here's something weird. They didn't give us a vertex, like they did in this problem. Oh, crap. What did they give you?
30 points.
What kinds of points are two of them? X-intercepts. So what form of the parabola do you suppose we're going to use here? The intercept form. Because they gave you intercepts. Okay, so we start out, if you get to choose, this is a good choice. But we don't really get to choose here because this depends on us having a vertex. They didn't give us the vertex, they gave us something else. And what they gave us were the x-axis intercepts, which means that's the form we have to choose. Does anybody remember the intercept form without having to look it up?
Y equals A parentheses X minus P parentheses X minus Q.
Where P and Q are the x-intercepts. So, to begin filling this out, I'll leave some gaps here. This one's going to be x minus what? 4, good. And this one will be x minus 24. And A, what's A, do you think? Again, that's the one thing we don't know. But I left the x's there. What are we going to... We got too many variables. We got a y and an x here and an x here and an a here. We got 3 variables. We can only have one to be able to solve. What do? What's the other point? 0 for x, 9.6 for y. That's the extra point that they gave us. And y is 9.6 and x is 0 twice. Do you see that? X gets replaced with 0 or y gets replaced with 9.6. Now we have an equation with only one variable. That's the goal. Now we clean it up. It's going to be 9.6 is equal to a times -4 times -24. Y'all see that? And 4 times 24 is 96. Negative times a negative is positive. So this, notice what I'm doing, taking the result of that, sticking it on the front of A. It's all multiplication. I'm just used to seeing it on the front. It just helps me handle things better when this thing's on the front. So I'm moving it, which is legal to do because you can multiply in any order you want. Divide by 96. Does anybody know without their calculator what 9.6 divided by 96 is? 0.1. Very good. So we now have A. So we come back and write the equation with the y back in as a variable for generating all the others equals 0.1 times x minus 4 times x minus 24. So we come back to the form we started with, and there's our equation with the x's returned as variables and the y returned as a variable to generate all the other points. We have our A, and we already had these, but we had to use the one point they gave us besides the intercepts to find A. We come back and rewrite it just like we did the other one. Okay? So it says, write a function of S that models the temperature over time. What's the coldest temperature?
14.
What's that?
About 14.
It's no, the coldest temperature occurs at about 14. What's that? That'd be a great idea. That's good thinking. Did you hear what she said? Don't you just average P and Q and plug it in? Why? Because we're looking for the vertex. The coldest thing occurs at the vertex. How do we find the vertex of this? We average P and Q and plug it in. Right? Okay, so what's the average of -4 plus -24 divided by 2? 14. So we hit that one right on. That was a pretty good guess on my part. You guys probably guessed it too. So the average is 14. That's the x-coordinate of our vertex, right? Isn't that what we just found by averaging P and Q is the x-coordinate of our vertex? So this thing's vertex is going to be at 14 comma something, and it's that thing that I want, because that'll tell me the temperature. That'll be the y value of it. So I plug it in. Y equals 0.1 times 14 minus 4, 14 minus 24. 14 minus 4 is 10. 14 minus 24 is -10. Here's a 0.1, whole bunch of tens and a tenth here. What's that multiply out to be? What's 10 times 10? What's a tenth of 100? Positive or negative? Just what you thought. That's what the graph says. But you can't read the graph for this. You have to actually plug it in the equation. This could have turned out to be negative 9.92, and you wouldn't be able to tell the difference there. So you have to plug it in. But that's really good instincts. I'm glad you saw this. You said, well, to find the lowest point on this, we need the vertex. How do we find the vertex? Average P and Q, plug it in. This gives you the y coordinate of the vertex, which is our lowest temperature. And it occurs at 14 hours after midnight, 2 p.m., which is dumb, but whatever. You following? You see how we got all that? That's a lot of choices to make. You got to look at your graph and say, what did they give me? They gave us intercepts. So you start there. You find A by plugging things in. Then you use it. If they want something about the vertex, you have to find the vertex of this and interpret it. It's quite a lot of work. It's quite a lot of math. I haven't even hit the B part of this thing yet. They love this kind of question on an ISAT test and an ACT test. So whether you're going to college or you just want to pass the ISAT with a decent score, this is a really important concept. Luckily, it's easy. Here's what it says. B says, what is the average rate of change? That's a phrase you better learn. What is the average rate of change in temperature over the interval in which the temperature is decreasing? What interval is it decreasing? No, what x values is the function going down? What's asking?
Is it the slope? Like, that's what you're trying to
We'll get there. Yes, you're right. It is the slope. But what interval is this graph decreasing on?
Hours after midnight.
How many?
do.
14. The thing's coming down until x is 14. From there it goes up, right? So on the interval, this is how we say it, on the x interval from 0 hours to 14 hours, what is the average rate of change? This is an interval, not a point. That's why I put brackets on it. It's not a point. Average rate of change is what she said it was. What's your name?
Addie?
Addie. What Addie said with the average rate of change is a slope. So look, the graph's coming down like this. What we want to know is what is the slope from right here to right here? What do you need to find the slope of a line? Rise over run is great. A couple of points would work because we subtract the y over x minus x to find a slope, right? On this particular graph, on this piece of this particular graph, what is this point right here? 0, 9.6. Look at your graph. See it? What is this point right here when it stops decreasing and starts increasing?
Negative 14, or 14, negative 10.
Yeah, that's what we discovered. It's the vertex where it quits going down and starts going up. So we know what the coordinates of this point are because we found it up here. You with me? What's the slope between these 2 points? Because that's the average rate of change. Average rate of change means slope, which means find the slope between this point and this point. The beginning point and the ending point, you draw a straight line and you find its slope. That would be negative 10 minus 9.6, y minus y, over, in the same order, x minus x. That's the slope, or average rate of change. That's what it is, that slope. So that's negative 19.6 over 14. What is that?
Negative 7.
Oh, thank you. That's excellent. Can anyone interpret what that means in the context of the problem? And I'll tell you how you start it. You start by saying, on average, because that's what we found was average rate of change. On average,
Decreases.
what does?
Temperature.
The temperature drops
1.4 degrees Celsius per hour.
Excellent. That's what it is. Because this turned out negative, the temperature is dropping. That's how we interpret that. But that's what the slope is a rate of change. And the time and the information on the axes that we have here is degrees per hour. On average, it drops 1.4 degrees per hour. Now, it drops a heck of a lot more quickly right here at the beginning than it does at the end. But on average, it drops 1.4 degrees per hour. We good? Okay. And the other part says, decreasing, now increasing. So we got to do this very same thing with the increasing part. In other words, we got to find the slope of that line. So I need this point. What is this point right here?
24, 0.
And we have this one. So to find the slope here, we would take negative 10 minus 0, the y's are on top, over in the same order, 14 minus 24. And that is negative 10 over negative 10. That's 1. 1 what?
Celsius.
Degrees Celsius per hour. Is the temperature going up or down? How do you know? Positive. That's the increasing. On the part of the graph that is increasing, the average increase is 1 degree Celsius per hour. And then it says, and whenever you see this in a math book, this is what you do. It says compare the average rate of change. The temperature dropped more per hour than it rose. Because 1.4, the size of 1.4 is bigger than 1. So the temperature dropped more dramatically than it rose on the increasing part. That's how you do a comparison. Which one's bigger in size in this case? You can see the graph that they drew is better than mine, but not much. Mine's pretty good. It's pretty actually. They drew the graph with the grid on it there at the bottom of page 77 to show you those two red lines that we were looking for the slopes of. Turn page. Okay. Now this is another one. That average rate of change thing was one of the new concepts. Luckily, it wasn't too hard to do. It means slope. So find the endpoints of the interval you're looking at. Find the endpoints and find the slope by subtracting the y's over the x's. You got it. You have to be able to interpret it in the context of the problem based on the units on the axes. This also is a new concept, and luckily also this is not hard, but it's kind of weird and strange. I want you to look at example 3. We're going to try to get the concept as we do the example. Here's what it says. Stay with me. I'm looking at a table now. I'm not looking at a graph. I'm looking at a set of data. Listen to what it says. NASA can create a weightless environment by flying a plane in a parabolic path. The table shows heights in feet of the plane, t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. It's called the vomit comet. They use it for shooting movies and for doing experiments in a weightless environment, a truly weightless environment. And they go up in the atmosphere. And planes can only go about 10, 12 miles up before they have to come down because they haven't got any air going over their wings. There's not enough air up there. So they take off at a really sharp angle. And then they get up there to the top and they kind of skim across the top of the atmosphere. And then they let the thing dive. And the whole path is a parabola. And as you dive, it's like being on an elevator that doesn't have a bottom. Somebody just drops the elevator through the shaft. You start to float because you're dropping at the same speed the airplane is. You're falling to the earth at the same speed the airplane is. It feels like on the inside of the airplane, you're in the cabin, you're just floating around. Then it comes down a ways, and rather than hit the ground, which would be really bad, rather than hit the ground, near the surface of the earth, it starts to come out of it. As it starts to come out of it, everybody slowly settles back down and they get their feet back. And then it'll do it again if they need to shoot some more. That's how they shot all of Apollo 13. All that weightless stuff, 20 seconds at a time. Because you can only drop for 20 seconds before you got to come out of a dive. Anyways, so look at the table that we've got. We've got every 5 seconds starting at time equals 10 seconds, up to 40 seconds. And then we've got the height of the airplane in those cases. Notice it goes from 26 to 29 to 30 to 31, and then 32, and then 32, and then back to 31. So it's starting to come down in those 40 seconds again. Okay? How do we tell how to model that? Well, it's going to be a quadratic, and here's how you do it. I'm not actually going to do the arithmetic. You guys are going to have to come back to this example and see how to do it. Look at what they're doing right here. Right here. Look at this part right here. What they do is they take the y values. Notice what they wrote. They wrote 26.9, 29.25, 3,600. Those are all from the table. They just wrote them horizontally. Then they subtract them. They take 29,025 and subtract 26.9, and they get the 2,125, that blue number. That's what those two black things are coming together. They're going to say subtract. And when you subtract, you always take the one on the right and subtract the one that's just to the left of it. Are you with me? So what they're saying is that the difference of the first two is 21.25. The difference of the next two is 15.75. Then 10.25, 4.75, negative 75, because now we're taking a larger or smaller number minus a larger number, and then negative 6.25. If when you do that, all of your first numbers, we call them first differences, if they're all the same, then a line is your best fit. But if they aren't the same, as these are not, you do it again with those numbers. So we take the 15.75 minus the 21.25, and we get negative 5.50. We do it with the next two numbers, taking the right one minus the left one, we get negative 5.50, negative 5.50, negative 5.50, negative 5.50. When all of the numbers are the same, when you're subtracting, you just keep subtracting differences. If all the numbers turn out to be the same in the second set of differences, then a quadratic is going to be your best fit. If the first differences were the same, then a linear will be your best fit. If it takes three sets of differences, then a cubic is your best fit. In our case, it was the second differences that turned out to be the same number. They don't have to be negative 550 every time. They just have to be the same number. Then you say, okay, good. A quadratic equation is going to be our best fit. You go, okay, I can do that, but now what? Now you make your calculator do the work. This is the calculator part of this lecture. So grab your calculators, and things are going to be just the same as they were when you fit a line, with one tiny exception. It's pretty easy to make it happen. So hopefully the person watching this can see this. I hope you guys can. Okay, so here's how we make your calculator figure out the parabola. And we by doing those differences, we figured out that parabola is going to be best. So once that's in your mind, by doing those differences, and I'll be quite honest with you, doing those differences is the dumbest thing in the world. But you're going to have to do it on an ISAT, which is dumb, and you probably will have to do it on a test out of this, just one. But generally what I do is I don't bother to take the differences. I never do that. I just do what I'm about to do here, and I'll be able to tell whether it's going to be a quadratic or not. So go to your stat. We're going to fit a curve, just like we did before. So you go to your stat, dump your lists, and in list 1, put the times, 10, 15, 20, and so forth. 10, 15, 20, 25, 20, 30, 35, 40. Okay. And then put those monstrously huge numbers in the list too. Make sure your lists are the same length, and then everything in list 2 has 5 digits, and everything in list 1 has 2. At least that's a check to see that you didn't make any massive errors. Everybody got that? This is 4, right? What's the next thing that we do in this process from what you know?
Window.
Fix a window. So we go to the window, and I'm going to let my x minimum be 0 so I can see the ground. No, that's the time. I'm still going to let x be 0. Maximum 50? No, I'm gonna make it go 70 by 10s. What's your smallest height? And that's not necessarily the first one, but it looks like it is in this case. 26.9, so I'm gonna go 2,500. And the biggest one is 31,620, no, 32.1, right? 32,100, so I'm gonna go to 3,500. 2,500 to 3,500 is 1,000, so I'm gonna go by hundreds. Okay, we got her? Now remember how to fix the window? What's the next thing we do? Not graph yet. Make sure your plot is on. What?
Is it 35,000 and 25,000?
Is it? Probably. I'm sure you're right. Yep, you're right. Thank you for that. It's got to be thousands, which means the scale's got to be thousands. Thanks for that catch, because I would have wondered where my points are. Thank you for that. Now hit graph. After you turn the plot on and make sure your y equals is empty, turn the plot on, hit graph. Oh, I think my plot's not set up properly. It isn't. It's got to be, hang on, I got to fix my plot setup. Come on, quit it. There we go. Now, people, when I'm trying to decide, I have not fit a curve to this yet. When I'm trying to decide what kind of curve to fit, I never do those stupid common differences. You're going to have to practice it because it's a skill they want you to know. It's dumb, my opinion. But I'm teaching it to you because you may have to be tested on it. So do those common differences when they ask you to. We decided it would be quadratic. I never do that. I get to this far and look at that thing and say, yeah, looks like a parabola to me. Duh, right? Okay, so it looks like a piece of parabola. So now that's what I'm going to fit based on what it looks like rather than these common differences. So I have two pieces of evidence that it's going to be a quadratic. So now what's the next step after you see the points plotted? You do, next big thing to do is to go back to that. We want to fit a curve to it now. We want to fit something to it. Over to calc, and this is where it will be different. Instead of choosing a line, you choose a quad reg. It's the only difference because we want to fit a quadratic to it now. Quad reg. It's number 5 instead of 4. So hit enter. And then depending on your screen, depending on what you have there, you need to put X list as list 1, Y list as list 2. And then in the storage area, that's where the vars comes in. You go vars, Y vars, function, Y1. Remember?
Same thing as the other one.
Same as the other one. The only difference in this is that you choose quad reg instead of lin reg. Question? Sharon?
Is it supposed to come with that?
No, sometimes it won't. Different operating systems have different things.
Or do I just put in a line in the line?
Log, or yeah. List 1, comma, list 2, comma, vars, Y vars, function, Y1, enter. Same information, it's just entered slightly differently. So I'm going to hit calculate. Here's the equation of fit in y equals screen. Here is clear evidence that it fits nicely. You following me there? Now let's see what they wanted us to do with this. After we find an equation, we've decided it should be quadratic, we fit the quadratic, and went through all that work, and now it says, after about 20.8 seconds, passengers begin to experience weightlessness. 20.8, is that an X or a Y value? X. So we go, to make a prediction, we go second, trace, which is calculate, a value, an X value at 20.8. Are you with me? Right about here on the airplane's way up, it's still moving up, but right about here it begins to experience weightlessness, because right about here is where the plane has the steepest slope. Well, actually, it's steep down here too, but it's making a tremendous effort to accelerate up, and so if you just let yourself float, then you'd float to the back of the plane. You wouldn't float, you'd slam to the back of the plane. But it's starting to slow down a bit here as it reaches its peak, and that's when you start to think, oh, here we go. It's awesome. Okay,
I have a question.
so the height at which it occurs is around 30,800 feet. What?
Oh, once you get to L1, L2, Y1, then you hit graph, right?
No, you hit enter. You have to make it execute. Yeah. You've given it all the information, but now you have to tell it, okay, now please do what you're supposed to do with this by hitting enter, okay? Yeah, that's a very common error. It's amazing.
Graph it after because I got my windows and everything.
I don't think you use it. Yeah, see, that's what she was telling me. She was like 3,000. These are thousands of feet, so this should be thousands. Okay. Okay, so let's do one more. Let's see if we can get all the way through this one more time. So go over to example 4. I got to show you one more thing that's pretty important here. We got to hustle. So go over to example 4. Start over to stat edit. And dump your lists and get that stuff entered. And see how far you can get in the process. This is a different one. We're talking about miles per hour and gallons per mile. No, miles per gallon. Miles per hour, miles per gallon. Notice that we are not doing the common differences on this. We're just going straight to the graph and see what we can tell what fits it best. We able to get that far?
Can I have your attention, please? We have a Jeep Cherokee that the alarm is going off in the parking lot, 1MB1573. The alarm is sounding in the parking lot. Thank you.
Everybody got it? We haven't got much time to dawdle here. You guys need to hurry it up. You got to get a graph. It says, what is the speed that you should travel to optimize your gas mileage? What are we looking for? How fast should you make this car move to optimize your gas mileage? In other words, when you're getting the best gas mileage, what do we need to find on this graph to answer that question? It starts with a V. Yeah, look, the vertex right here is going to be where you get your maximum gas mileage, because gas mileage is on the Y. You find a vertex. I'm about to show you. Watch carefully, because this is new. Are you ready? Watch. You go second, trace. In this case, because it's opening downward, a maximum. We want to find the maximum. So hit that. And it behaves just like finding a zero. It says left bound. So move your cursor until you're on the left side of the mountain, but not too far down. See, mine's right there. That's a left bound for this point that I'm looking for. Hit enter. And it says a right bound. So now crawl up over the top of the hill until you're going down the other side so that you're clearly to the right of that maximum. And hit enter. Don't guess. Hit enter. And it will go right to the vertex. So the answer is, you should go about 48.5 miles an hour And if you do, you will get almost 26 miles to the gallon, your best mileage, but only at this speed. So it's not very fast. You want to go faster, you're going to sacrifice mileage. It's going to cost you more money. But if you want to maximize your dollar for gas, you go at about 50 miles an hour. Any faster or any slower, and your gas mileage will go down. We follow? I have to show you one more thing. What if I asked you instead, here's your graph right here, and what if I asked you instead to find the miles per hour when you get 20 miles to the gallon? You can't do this. Listen, if I say you want to get 20 miles to the gallon, how fast should you go? You can't do this. You can't go calculate a value at 20 because that's a speed. I gave you gas mileage. I gave you a Y value. And there's no way to calculate that directly. So here's what you do. You go to the Y equals screen because that's where Y things go. And you go down to Y2 and you put the number 20 in. Because that's a gas mileage, 20 miles per gallon. That's a mileage. That's a Y value. Now hit enter, or hit graph, excuse me. Wait. What we're saying is that you will get 20 miles to the gallon at this speed and at this speed. How do you find that? It's called an intersect. Stay with me. Go second, trace, and intersect. Get your cursor closer to which one of these you want. I want the slower one. I'm just showing you. Get it closer to that one. Just get it closer than the other one and hit enter, enter, enter. The answer is 28 miles an hour will get you 20 miles per gallon. It'll also happen over here at more than 50 miles an hour. You can find that one as well by doing an intersect. If you need the assignment because you're doing it on paper, hang around a bit more. If not, you can go. It's in Big Ideas Math. You need to get it done over this 3-day weekend. I gotta go fix it then. I will adjust it. You'll find it there later. If you're doing it on paper, here it is. Are you ready? 1 to 13 odd. 16, 17, 23, 24, 26, 27, 29 to 32, and 35. That's 18 questions. Make sure you have a piece of graph. Thank you. Make sure you have a graph. Lots of thought again. If any of you have a parent signed syllabus, that would be nice to have before the weekend as well.
I have the back here for that. Can I show it to you?
What's that?